is rho L by A. So anyhow, if length or area of cross section changes, there is change in dimension, either length changes or area of cross section changes, or both changes, there will be change in resistance. If nature of material changes, there will be change in resistance as well as resistivity, or due to resistivity only there will be change in resistance. Okay, today we shall see the effect on resistance, that also we have to see. Effect on resistance. When a wire is stretched, if a wire is stretched, then what will be the effect on resistance?
Sir, do your camera little up, sir.
Yes?
Sir, do your camera little up, sir.
So effect on resistance when a wire is stretched. So suppose this is the wire of length L1. Area of cross section is A1. Its resistance is R1. Now this wire is stretched. So when the wire is stretched, what will be? Its length will increase. If two different wires are given, then also we can compare the resistance. When wire is stretched, then also we'll compare, we'll find. So in general, what is this ratio? So we are saying what is the rate? R2 to R1. R2, suppose the material is different than rho. So general formula for R2 by R1 is rho 2 over rho 1, L2 over L1 into A1 by A2. This is general case. Whether wire is stretched or not stretched, or it is made up of two different material, if you are asked to find the ratio, we will consider this one. If material is same, L2 and L1 will be same. If length is same, L2 and L1 will be same. Area of cross section is same, thickness is same, this will be cancelled. This part will not be there. So this is the general formula for ratio of, in general, ratio of resistance of two different wires. So this will be the general formula. Now, when the wire is stretched, what will happen? What are the same? What are the physical quantity that will remain same? When wire is stretched?
Resistance.
Yes?
Specific resistance.
Specific resistance will be same. Any other? What's about volume? Volume of the wire?
Same.
Volume of wire will be also same. So now we are going to discuss when wire is stretched. This was the general formula, and you will always keep in mind when you are asked to find ratio, this will be the formula. If material is same, then this one will not be coming. Length is same, this one will not come. Area is same, this one will be 1. So when wire is stretched, its resistivity and volume will remain same. That is rho 2 and rho 1 same. Volume, what is the volume of this wire? How will you calculate? What is the volume of this wire?
Length
Yes.
into area of cross section.
Area of cross section into length. Sorry. So in this case, A1 into L1 will be equal to A2 into L2. So what will you get? This L2 by L1 will be A1 by A2. Now if you use the ratio, resistance of the two conductor, what is that? Since this R2 by R1 is what? Rho 2 by rho 1 into L2 by L1 into A1 by A2. So what will be here? Rho 2 and rho 1 are equal. So it will become 1. In place of L2 by L1, we can write A1 by A2. Okay, suppose this is your second, this is first, and this is third. So combining all the relation, what will you get? So this first, second, and third will give what? Rho 2 by rho 1, 1. So this R2 by R1 will be L2 by L1. In place of A1 by A2, we can write L2 by L1. That is L2 by L1 whole square. Or it can be A1 by A2 whole square.
Sir, once again, this one I have not understood.
Okay. So this R2 by R1. What is that? Rho 2 by rho 1, this is 1. L2 by L1. Now A1 by A2 is what? L2 by L1. So question 1. Question 1 was what? L2 by L1 is A1 by A2. So So in place of A1 by A2, we have written L2 by L1. So what will come? L2 by L1 whole square. Or you can say I will express in terms of area only. In place of L2 by L1, we can write A1 by A2. So it is A1 by A2 whole square. Is it clear now?
Yes, sir.
Yes. Now sometime we will be given radius of this wire or diameter of the wire or thickness of the wire. Then this is suppose R1 and this is R2. What is area? So A1 is pi R1 square, A2 is pi R2 square. So A1 by A2 is how much? What will be?
Pi R1 square by pi R2 square.
So pi will be cancelled.
Yes, sir.
A1 by A2 will become R1 by R2 whole square. It is already square over this. So R1 square over R2 square whole square. That is to the power 4. Yes.
Yes, sir.
So when wire is stretched, what we got general formula? So when wire is stretched, this R2 by R1 we got L2 by L1 whole square, or it may be A1 by A2 whole square, or it may be R1 by R2 to the power whole 4. So when wire is stretched, we will use this formula. Sometimes the wire is stretched to double its length, or it is stretched in such a way that length become double. That means in that case, what is that? L2 is twice L1. What will be the effect on resistance? If wire is stretched in such a way that first is its length become 3 times. Its radius become half. Its area of cross section become 1/3. Okay. You are asked what will be the effect on resistance if wire is like this. What will be the effect on resistance of a wire? Resistance, okay. If wire is straight, is this. Okay, suppose this one given. What will be the answer?
It will increase by 9 times.
First one,
9 times it will increase.
9 times, okay. Second one,
16 times.
16 times.
16 times. Very good. Third one,
9 times.
9
9 times.
times. Very good. Yes. Fourth one,
4 times.
how much?
Four.
4 time will not be there.
4 by 9.
4 by 9 is also wrong.
2.25 times.
2.25 times is the correct answer. Okay. Yes. So you understood. So first one is length become 3 times. So what will you use? This R2 by R1 will be L2 by L1 whole square. This is 3L1 by L1 whole square. So it is 9. That means this R2 will be 9 times R1. So answer will write the resistance will become 9 times. First one. Second one you are given. In the second one you are given this R2 is half of R1. First one, this one was given. This L2 is 3 times L1. Second one, radius become half. That means R2 is R1 by 2. So we'll use this one. So this R2 by R1 is R1 by R2 whole to the power 4. In place of R2, we'll write R1 by 2. So it will become 2 to the power 4, 16. So R2 will become 16 times R1. Third one is area cross section become 1/3. So in third one we are given this A2 is 1/3 of A1. So use this one, this relation. So R2 by R1 is A1 by A2 whole square. In place of A2, we'll write A1 by 3. So 3 will go up, A1 cancel. So 3 square. So R2 will be 9 times R1. Now this length increases to 150%, or it may be by 50%. So both adjective will be or preposition will be, not adjective, preposition will be giving the different meaning. Here both are same thing. Here increases to 150% or increases by 50%. If suppose it is written increases to 200% or increases by 200%, then it is different. Increases to 200% means the length become double. Increases by 200% means 200% is the increase. So length will become 3 times.
Triple.
So always see the preposition, what is given here. So in this case, we are given, so this L2 is what? 150% of L1. What does it mean? 150 by 100 L1. So 1.5 L1. If it is increases by 150%, then what will be? L2 will be L1 plus 150% of L1. That is 250%. 2.5 times will become. So this R2 by R1 is L2 by L1 whole square. So 1.5 L1 by L1 whole square. So 1.5 whole square, that is 2.25. So R2 will be 2.25. This way you will have to give answer. The copper wire of length 5 meter area of cross section 2 millimeter square. What is what you say? The resistance of copper wire. The resistance of copper wire of length 5 meter, area of cross section 2 millimeter square is 0.5 meter. Find the resistance of nichrome wire. Of length 2 meter, area of cross section 5 millimeter square, given, or if the ratio of resistivity of nichrome and copper be 25:2. Suppose this one is given.
So please do little.
Camera up, sir.
Resistance of copper wire of length 5 meter, area of cross section 2 millimeter square is 0.5 ohm, not meter. 0.5 ohm. Find the resistance of nichrome wire of length 2 meter, area of cross section 5 millimeter square. If ratio of resistivity of nichrome and copper be 25:2.
Sir, please read the first line.
Yes, the resistance of copper wire of length 5 meter, area of cross section 2 millimeter square is 0.5. Find the resistance of nichrome wire of length 2 meter, area of cross section 5 millimeter square, ratio of resistivity of nichrome and copper is 25:2. So you can use any symbol. Suppose you are taking resistance length of copper wire. You can take L1, you can take whatever symbol you can use. So suppose for copper we are taking 1 and for nichrome we are taking 2. Then what is given? This L1 you are given 5 meter. Area of cross section you are given 2 millimeter square. R1 you are given 0.5 ohm. Now second one is length of nichrome wire, L2 we are giving this symbol, 2 meter. Area of cross section is 5 millimeter square. R2 we have to find. And this resistivity is rho 2 is to rho 1 you are given 25:2. So in this type of situation also you will find, you will use the formula of that ratio 1. So what was the general formula for resistance ratio? R2 by R1 is, as here material is different, so rho will be different. Rho2 by rho1 into L2 by L1 into A1 by A2. So this R2 we have to find. R1 value you can write here, no problem, 0.5 ohm. Now this ratio directly you are given, 25 by 2. So we'll write 25 by 2. L2, 2 meter. This is 5 meter. Area of cross section, A1 is 2 millimeter square by 5 millimeter square. So as both are in millimeter square, they are coming in U ratio form, so no need to change. Millimeter square cancel. Meter cancel. If it is given in centimeter, both are in centimeter, no problem, will not change. This is the benefit of this ratio method. No need to change in same unit. If numerator and denominator are in same ratio, in same unit, no need to change in SI unit or CGS unit or whatever it is. This may be different unit, this may be different system, no problem. So what will be this R2? 0.5, 5 25 cancel, 2 cancel. What will be? Into 2 only. Millimeter square cancel, meter cancel. 5 25 cancel, 2 cancel. So this one will be 1 ohm. So resistance of this particular nichrome wire will become 1 ohm. So this way, numerical you have to solve. Many are given your book. You have to solve. Next we shall see Ohm's law. Yes, shall we leave up to here?
Thank you, sir.